So hello people, welcome back to the channel, and this video is going to be a slightly different from the usual ones that we create. That's the LeetCode daily question solution that will also be coming on the daily basis also, but this is a new series, you can say, that I'm going to start, where I'll be posting contest solutions every week or every bi-weekly whenever the contest occurs. So this was just for the intro, and let's dive into the video directly, and let's just move to the first question, that is Apple redistribution in the boxes. And yeah, for example, so I guess I'm having I'll just reset it to default without showing the code. Yeah, okay, so in the first question, that is 3074, we are having apple redistribution in the boxes, and in this we'll given an array apple of size n and an array capacity of size m, and there are n packs where ith pack contains I apples, and there are m boxes as well, and the ith box has the capacity of uh, I apples, and we have to return the minimum number of boxes that we need to select to distribute these n packs of apple into boxes. And note that apples from the same pack can be distributed into different boxes. For example, if we are having three, so we can divide three as 1 and 2 also. So what we have to do, we have to return the minimum number of boxes. So how we can approach this question is that we need to firstly see that we need to pack each and every apple. So no matter, we can redistribute them also. Like for example, three, as I already told, that three can be distributed in the boxes of size 1 and 2. It's not mandatory that we need to have the minimum size of the pack and the box. So it's clear from here. So what we can do is we can just total the total number of apples, that comes out to be 6, and from the capacity, what we can do is we can choose the boxes with the capacity 4 and 5. And so what we can observe is, if we'll do the sum, we just have to find the next number of consecutive elements, which will give me the sum maximum from that, and there's no constraint that we need the absolute difference between them should be minimum, or it should be just the next greater. So there are no constraints. So what we can do is we can just sort the capacity array, and then we'll be moving my from the end to the left, and we'll be keeping a track that whenever my all apples are accommodated in the total number of boxes, we'll be just returning that number of boxes which are required. Okay, so let's just directly dive into the code, and let's here just to apples I, and so let's count the total apples firstly. I'll Okay, let me just moment total apples, and that are initially 0, and we'll be traversing the apple array, that apples array, for int apple and apples. So the total apples will be apples plus equal to apple. Okay, so now we have the total number of apples. So now what we can do is we can either use a priority queue, but that's just like using more space. So we'll just directly sort the array. Arrays dot sort capacity, and then we'll be moving from last, that for int capacity. Okay, capacity is used, so box size, let's say box size equal to the last element, that is capacity dot length minus 1, capacity dot length minus 1, and while box size is pointing towards the 0th or bigger element, we'll be decrementing its size, that is box size minus minus. And also let's have an answer variable where we'll be storing the total number of boxes which are required, and answer equal to 0. Okay, and now let's do we'll be checking that if my capacity sorry, if total number of apples are still greater than 0, we'll be doing answer plus plus, we'll be incrementing the answer. Or else we can see that if we have accommodated all the apples in the boxes, so we can just break out of the loop, that is if total apples equal to 0 or these are less than 0, or total apples less than 0, then what we can do, okay, so total apples less than 0, we can just break. And then what else we'll be doing is we'll be removing the subtracting the number of apples with the box size. Okay, so capacity box size. Okay, and now let's just return the total answer, and let's run it once. Okay, yeah, it says the expected answer matches. Now let's submit it. Yeah, and it gets accepted. Okay, so now let's move towards the next question, that is okay, maximize happiness of selected children. And let me just so I'll just reset the code. Reset. Okay, so in this we'll give in an integer array happiness of length n and a positive integer k. So there will be in children standing in a queue where I child represents the happiness value, happiness I am, and we have to select the k children from these in children's in k turns. And when in each turn when we select the children, just when we select a child, the happiness value of all child that have not been selected will decrease by 1. And we know note that happiness value cannot become negative and gets decremented only if it is positive. So we have to return the maximum sum of happiness of the selected children, yeah, which we can achieve by selecting exactly k children. Okay, so for example, in the first array we are given we need to select 2 children, and for example we select the first children with the maximum happiness, that is 3. Then after that all the children with all the children which were not selected, and their happiness value will get decremented by 1. So this becomes I'll just okay, so initially I was having an array of 1 okay, 1 2 and then 3. Okay, so if I just yeah, if I have chosen 3, so chosen 3, so that means now my current array will look like 0, because every other value will be get decremented by 1 and 0 and 1. Okay, and now what I have done here, my k will be equal to 1 because I've selected one child. Now again I have to maximize the happiness, so I'll be selecting this child. Okay, so if I choose 1, my k will become 0 and I no more have to select any more children. So my total answer will be 3 plus 4, 3 plus 1, that sums up to 4. Okay, so that is the answer here. And in the second time we are having the happiness area of 1 1 1 1 1. Oh, okay, so this is a nice case, and let's just copy it, happiness. uh, yeah, and this is it. So like first what we'll be selecting the maximum value. So let's say we chosen 1, and now my k will be equal to 1, and after this all other children value will become 0. Okay, so my now happiness area will look like, I'll just copy, it will be like yeah, 0 0 and 0. Okay, so now I cannot perform any other option because it's stated in the question only that we can select the happiness value and cannot be negative. Okay, so even if we select that will be making no sense because okay, so basically yeah, even if we select that it will be having no sense because we'll be having at the end answer 0 only. And so this is the second test case. Okay, so what we can do for this is we can use a priority queue to add the happiness value, and we'll be keeping the track of how much we need to subtract from it. Okay, and then let's just have a priority queue. We'll be having a max heap. Okay, priority queue of integer, let's call it max heap, it is equal to new priority queue. And here let's say we are having two elements that are a and b. We'll be using a custom comparator, so we have to return a b minus a. Okay, and now let's just travel in the happiness array and update the priority queue, that for int happiness, let's just zoom in a little bit, happiness and okay, so it's already happiness int happy. Okay, let's do int happy in happiness. I'll be doing a max heap dot add happy, and if I'll just let's just return -1, and here I'll try to print the max heap so you will get a better view. Print ln max heap, and let's run it once. So you will be getting a okay, it says compiler cannot find symbols. Okay, print ln, and let's run it. Yeah, so here you can see this is how my priority queue looks. It's not a nice way, but you can see that 3 is on top, and then when the heapify function will be called, then my 2 will be on top, and then the last one will be there. Okay, so now as we have already printed the max heap, so I hope you get. And now what we'll be doing is, let's have a long, because the return time is long, answer that will be initialized to 0, and we'll be keeping a track of how much we need to subtract. So initially we need to subtract only 1, only 0. Okay, so let's keep a track of sub. So now what I'm trying to do is, let's have another test case. So for example, if I will not, you can do it using brute force also, that firstly you will be sorting both the arrays, and then you will be you will be present in the last element and decrementing all the other values by 1. But if you see that we have to, when we decrement the value, will be maximum value. Okay, so let's have a good example. I would say 5, 8, 9, and let's say 6 is there, then 7 is there. Okay, and let's say 2 is also there, and we have to choose k is equal to 3. So now firstly we'll be become the 9, and my k will become 1, k will become 2. Okay, and currently my sub is 0, that is the number of times I have to subtract is 0. Okay, now I have to subtract 1 from all the other elements. But if we look closely, then we have to we'll be subtracting 1 from the maximum element, because we have to pick that only. Okay, so after 9, every element will be get decremented by 1. So this array will be looking like, uh, let's remove 9 and decrement each of one of these: 4, 7, 5, 6, and then it will become 1. Okay, so now I have decremented each of them by 1. Now what I'll be doing is, I'll be firstly picking the maximum element, that is here 7. I'll be become 7, and then my k will be equal to 1. Now again I'll be have to decrementing each and every element, that is, let's just copy this once again and paste it. So here my 7 gets removed, and 4 becomes 3, 5 becomes 4, and my 6 becomes 5, and 1 will become 0. Now my k is still left, so I'll be become the max element once again, that is 5. So 5, and now my k becomes 0. So what we'll be doing is, we'll be keeping a track of subtraction, like at which iteration it is the number is present, and then we'll be removing, we'll be subtracting that much particular value. For example, this is the first iteration, so we just have to subtract 1 from the maximum number, that is 8. So in the next iteration we are at the second iteration, so we have to subtract 2 from the next maximum number, that is after that was, I guess, 7. So this statement is like 9 minus 0, this is the first iteration, plus 8 minus the iteration, let's say iteration, and then plus 7 minus ith iteration, so which in this case comes out to be 9 minus 0, plus 8 minus 1, plus 7 minus 2. Okay, so and this will sum up to, again, that is 9, 8, 17, and 17 and 5, 22. And this will also sum up to 9, 7, 16. Oh, okay, so what, I guess I made a mistake. 9 and 7, 16, 16 and 5, 21. Sorry. Yeah, so this will also sum up to 21. This will also sum up to, let's just use it as a custom test case only, so you'll be getting a better view. That is, let's just copy this array, copy, and I, okay, copy, and I'll be having my k equal to 3, and let's run code. It will be showing me the expected answer. Yeah, expected answer is 21, and as per our calculation, it's also coming out to be 21. Okay, so now let's just keep a track, and we'll be checking the condition that if the my current element becomes less than 0, is at that iteration where it will become less than 0 or equal to 0, will be not adding that element. Okay, so now let's use a while loop, that while not max heap is empty, and my k is greater than 0. Here I am just decrementing the value of k after every iteration. So I'll be checking that if my max heap dot p minus the subtraction is greater than 0, then only I'll be adding it to the answer, that is answer plus equal to max heap dot poll minus the subtraction, and I'll be moving my subtraction, or let's say the ith iteration plus plus, and at the end I'll just return answer. Okay, answer, and on the negative answer, let's just run it once. Expected answer comes out to 91. You can add one more quiz that if it becomes 0, then else we have to just break. So to improve our time complexity a bit, break. Okay, now let's run code. Yeah, and it gets accepted. Now let's submit it. Yeah, and it gets accepted. Okay, so there's one more thing related to this, that this was a question which was recently asked in, I guess, December only, in a Amazon interview. And so this is how you have to approach this question. This is a very famous question. And okay, so now let's just move towards the third question, and which is shortest uncommon substring in an array. Okay, so we are given an array ARR of size n consisting of non-empty strings, and we have to find an array answer of size n such that answer I is the shortest substring of array I that does not occur as a substring in any other string in array. If multiple such substring exist, answer I should be lexicographically smallest, and if no substring exists, answer I should be an empty string, and we have to at the end return answer. Okay, so let's have a look at the test cases. For example, we are given cab, add, bad, and c. So let's just have a look at each of the substrings. So first example, the first substring that comes is c, and c is present. Yeah, it's present in the last word. Then we'll have, let's say, a, and a is present in the next word only, so we'll just skip it. Then we have b, and b is present here, so let's just then skip it. Then let's move towards the next substring that we can find, that is ca. And yeah, ca is not a substring in any of the substrings, so ca could be one of the possible answer. Next, then this we are having ab, and ab is also not occurring again, so this is also one of the possible answers. Then we are having cap, and cab is also not occurring again, so these three could be the possible answers. So let's just have uh, the list of possible answers that we can have. And okay, so the possible answers are, for this, possible answers are string ca, ab, and cab. But in the question it's mentioned that we have to answer I should be the lexicographically smallest, so the lexicographically smallest of these three substring is ab, so that's why here at the answer I'm having ab. And then ad is not occurring again, because a is as a substring whole is occurring in many other words, d as a substring is occurring in bad, and ad together is not occurring in any other words, so we have to return an empty string. And then we are having is BA. So if we look, okay, sorry, BAD, and okay, sorry, AD as a together is occurring in bad, so that's why it's an empty string. Sorry for the confusion here. And then we are having B. Let's say B is occurring in this, and then A is occurring on the other words. Then D is also occurring in the other words, but BA together is not occurring in any other word, so it's answer. And AD is not a possible answer because ad as a word is present in the second word, and bad could be the possible answer also, because but we have to choose the lexicographically smallest. And for c we are having no answer because cab in itself there's c present in it. Okay, and c is the only possible substring for this, so we will be having an empty string instead. Now let's just have a look. So now let's move towards the coding part for this, and as you can see the constraints are really low, that it's n less than equal to 100 and the length of the string is also less than or equal to 20. So we can obviously there would have been a possible better solution, but I was not able to find that. Somewhere I had an approach of using a try, but I was not able to apply it successfully. And so now let's get directly into the coding part, and for this what I'll be doing is I'll be using a hash map to store the occurrences of each substring, of all the possible substrings, basically C, A, C, A, B, A, B, and each and every substring. Okay, so let's use a hash map, a map of string and integer. Let's call it substrings. That is equal to new hash map. And then what I'll be doing is, let's just use a for loop, that for int I equal to 0, I less than array dot length I plus plus, and let's use a set of string, and that is duplicates, that is equal to new hash set, and then let's have the current word, that is string word will be equal to array I, and let's have two pointers, that is for int left equal to 0, left less than word dot length, then left plus plus, and for int right equal to left, right less than okay, right less than or equal to word dot length, right plus plus, and then what I'll be doing is, let's have a string substring that will be equal to word dot substring left and right, and what I'll be then checking is that if my duplicates dot contains sub, I'll be having to continue it, or else what I'll be doing is adding it to the duplicates dot add sub, and also I'll be updating its frequency in the substring map, that is substrings dot put sub comma map substrings dot get or default sub comma 0 plus 1, okay, plus 1, and then here by now we have created the substrings map, and let's have the answer array, that is string answer, that will be equal to of size string and array dot length. Now what I'll have to do is that for int I equal to 0, again I less than array dot length I plus plus. Now here I'll be keeping a boolean that if that word is found in the hash map or not. So let's say currently it's false, then again I'll be generating all the possible, let's have the string word also, string word equal to array I'll be generating again all the possible substrings, that for int I equal to 0, sorry, left equal to 0, let's do left equal to 0, left less than word dot length left plus plus, then for int right equal to left, right less than or equal to word dot length, and then right plus plus. Then let's have the string sub again, that is equal to word dot substring left comma right, and then what I'll be checking is that if my substrings dot get the value of sub is equal to 1, that is it's occurring only once, here I'll be adding some condition that if answer I is equal to null, that is I haven't updated it, or my answer I dot length is greater than my current substring dot length, that is it might be lexicographically smaller, or in this case what I have to do, I have also it's given in the question only that we have to add the lexicographically smallest substring. So what I'll be doing is answer I dot compare to sub if this is greater than 0. In this case only also I'll be adding my answer I will be equal to sub. Okay, and so yeah, now let's just set here that my found is equal to true, and after this if my found still remains false, that is if not found, then at place I have to put the answer I will be equal to an empty string. Okay, and let's at the end just return the answer array and let's run it. Okay, so it says oh, has set is not declared properly. Has set. Let's run it again. A B null. Okay, so it's in case of null, it's not updating. If found, if not found, yeah. Otherwise, all the answers are correct. And okay, so the main issue is here only. And if not found, I have to set my answer I equal to empty string. Yeah, this is present in the inside of all scope only. And why it's creating an issue? Okay, so I guess that x, and if I just there might be some indentation problem where this for loop, yeah, this for loop ends here only, right? Yeah, and let's paste it. There should be not an issue. Okay, so is it setting my, let me just answer I dot length is greater than answer sub dot length, or answer, this is, everything looks fine only here, then what's the issue? Okay. Okay, so the potential issue here is this line, basically control shift, yeah. So here if my I have updated it, and otherwise it was getting that found was getting true every time. Now let's submit it, and most probably it will get okay, so it states the answer is wrong in this case, that is for H. Okay, let me just figure out. Okay, so I found the issue, that is that in this case, if let's say if my strings okay, so here the expected answer was H and dy, and here G and T, it's coming out in this issue because if I'll do the comparison between the two strings, dy is comparatively lexicographically smaller than H, and here also G is lexicographically smaller than T. So this is was the issue, and so this is the thing that I have to edit. And what I'll be doing is I'll be adding this or condition here, and then I guess it should get accepted. Okay, and let's just remove this condition. But here also I guess it should not be a issue anymore. But here also, otherwise I'll be just doing yeah, it was again an issue. Let's just remove this or condition, and we'll be in this case also I'll be updating else if I'll be adding another else, that if my answer I dot length is equal to the substring dot length, then what I'll be doing is I'll be checking that if my answer I dot compare to sub is greater than 0, in this case only I'll be updating my answer I will be equal to sub. Okay, now let's run it. It's getting accepted here. Now let's submit it. Yeah, and it gets accepted. Now let's move towards the last question, that is, let's just wait for it. Yeah, and maximum strength of k disjoint subarrays. Okay, so in this case, we are giving a zero indexed array of integers nums of length n and a positive integer k. And the strength of x subarray is defined as strength of sum 1, that is sum of one subarray into x minus sum of second subarray into x minus 1, and sum of third subarray into x minus 2, and sum of so on. Okay, so we need to select k disjoint subarrays from nums such that their strength is maximum. And we have to return the maximum possible strength that can be obtained, and note that select subarrays don't cover the entire subarray. For example, like 1 2 is a possible subarray, 2 3 could be okay, 2 3 could not be 1 because it's disjoint, yeah, they should, and 3 minus 1 could be 1, 2 2 could be 1, Okay, only two. Okay, on the other three could be possibly one, two, and three, and it's just stated that we don't need to cover the entire array. Okay, so for this, if you will have a, closer look, what this is a clearly dynamic programming question, because we have to find all the possible ways in which we can do this and to return the to get the maximum strength. So, for example, in the first thing which we can do is we can pick up these three subarrays together. So this will be giving me the sum of 1 plus 2, 6, 6 into k, that is x or k, let's say 3, that will be equal to 18. Okay, now what I'll have to do is minus the sum of second sum array, that is I also positive, like fortunately I'm having negative integers, so negative into negative will give me a positive sum, so I'll be able to maximize my strength even more. So minus 1 minus into minus 1 into 2, that will give me a sum of plus 2. Let's just write this here only, that is if I am choosing a sub array, okay, so yeah, my first subarray that I chose is 1, 2, and then 3. That will be multiplied by 3. Then my second subarray is minus 1. That will be multiplied by 2. And then my second subarray is, I guess, only 2. Third subarray, sorry. Yeah, only 2. And this will be multiplied by 1. So here this will be minus, and here this will be plus. Here it will be giving me the final answer. So if we do this, this will give me 6 into 3, that is 18. And here, as we are having a negative sign, so this will be eventually converted into plus, that is it will be giving plus 2, and at the end also I'll be having plus 2. So the total answer comes out to be 22. So this is how we have to do, and this is a clearly dynamic programming question, so we'll be eventually finding all the possible sub arrays to get the maximum strength. Okay, so now let's have a dp array that is of long type dp, and that will be equal to new so long, sorry, yeah, it's just an old habit, yeah, of size k plus 1. And as we know that we can have at max uh, three of the possible choices, like it will be present in the other, or it will be choosing, not choosing, or we'll be just completely skipping it. Okay, so of size, oh sorry, we'll be having just two choices if we are either choosing it or not choosing it with the so that's why we are having a 2D array of size k plus 1 and 2. So now let's just update this array, that for int I equal to 0, I less than or equal to k, and then I plus plus. We'll be setting that. Okay, let's instead use a for each loop only, that uh, for int I in dp, we'll be just doing arrays dot fill I comma with the minimum value, because as we have to return the maximum value, so we'll be initializing all the values with minimum value, and then we'll be setting dp 0 0 0 0 to be 0. Now let's start iterating over the num, that for int I equal to nums dot length minus 1, we'll be starting from the backward, then I greater than or equal to 0, and to I minus minus, we are just finding all the possible subarrays, and then for int j equal to minimum of, because we need to form the subarrays, so nums dot length minus I and k, because apparently we need to choose just k subarray, and also to keep the thing that it doesn't go out of bounds, and j greater than 0, j minus minus. So what I'll be setting is that dp j 1 will be equal to the maximum of, oh sorry, minimum, no, okay, nums I into, if my j mod 2, that is I'm not at even index, is greater than 0, if this comes okay, if j mod 2 is greater than 0, that means I'm at an odd index. So in this case what I'll be doing is I'll be having 1, or I'll be having minus 1, minus 1, because it's just because it's like, because some 1 plus 1 we have to do, or we have to do minus 1, because It's just this, nothing else. Let's say because we are at sum 2, we have to subtract this and not anything else. Into multiple will be multiplied by the maximum of dp j minus 1 and 0 comma dp j and then 1. And similarly my dp j0 will be updated as equal to maximum of dp j0 and dp j1. Okay, so and this is how we'll be doing, and let's just at the end return the dpk0 because it will be having a maximum answer. Let's run it. Okay, so it's not a statement because I forgot to add the return keyword. Compiler error is int. Okay, long. Let's run it. Okay, so it's funny that it gave me answer 0 0 I greater than equal to 0 I minus minus j equal to minimum of nums dot length minus I comma k, and j is greater than 0 j minus minus dpj1 will be equal to nums. Oh, so here I need to typecast also long, and let's copy just whole of this, and okay, long, and then dp maximum of dpj0. Let's, okay, it's still giving me, okay, let's find the potential difference. What could it be possibly? dpj1 long nums I into j mod 2 is greater than 0, so 1 otherwise minus 1 multiplied by the, oh sorry, multiplied by j plus we have to do. Let's run it. Yeah, and now let's submit it. Output difference, it's just because the okay, and let's, if I just convert, let's not typecast everything and let's convert just this nums into long. It gets converted into long and submitted, yeah, and it gets accepted. Okay, so this was it for today, and it was a long video. Obviously it might be overwhelming for you at the beginning, so if you want me to improve something, just comment it down, and hoping to see you today again. I'll be posting one more video only, and to see you next week, because I guess there's a bi-weekly contest next Saturday, so lucky for you, you'll be getting 2 videos on Saturdays and Sunday. Okay, so this was it for today, and thank you for watching. Drop us like and hit the subscribe button. Thank you.